example 1, we want to add and also subtract the two given polynomials. So I'll start with addition. So I'm going to copy down 3x to the fourth minus 2x cubed plus 7x squared plus 8x minus 1. And I'm adding to this the other polynomial, which is 5x to the fifth plus 9x to the fourth plus 2x squared minus 1/2 of x. The way you add or subtract polynomials is by combining all of the like terms through addition or subtraction. So, you can scan across both of these expressions, and if you want to go in a nice order, you could start with the largest exponent, and I see that's this one here. I have a 5x to the fifth, and there's no x to the fifths in this expression. That means I can simply just write down 5x to the fifth because it doesn't combine with anything else. And we can just proceed with every single term in both of the expressions. For example, I see a 3x to the fourth here, and there's a 9x to the fourth here. I'm adding these two things together, so that is going to be a 12x to the fourth. Okay, I guess next would be, okay, I see this negative 2x cubed. There are no x cubes over here, so we just get this negative 2x cubed. All right, now we'll go with the x squareds. I see a 7x squared and a 2x squared. That would give me a 9 plus 9x squared. Okay, next we have x's. We have this 8x, and we have a negative 1/2 x. So, if you'd like, you could just use decimals on this part. So you could say, oh, well, this is the same thing as negative 0.5x. So now when I combine this 8x and I'm subtracting, really, this negative 0.5x, I will have 7.5x. The last thing to do is deal with any constant terms. I see there's a negative 1 here. There are no constant terms in this expression, so the best I can do is just put minus 1 at the very end, and I scan my expression just to make sure that there's no like terms left over. There aren't, so that's it. This is what it would be to add these two polynomials together. Just go through term by term, adding or subtracting, if we have like this negative, the coefficient in front of it. So we'll just repeat this process, but now we'll subtract these two expressions, and I'll be more specific when I write it out. I want to do 3x to the fourth minus 2x cubed plus 7x squared plus 8x minus 1, and I want to subtract 5x to the fifth plus 9x to the fourth plus 2x squared minus 1/2 x. One approach you could take is distribute this negative to every single term inside the parentheses of the second expression. And actually, we can just get rid of the parentheses on this very first term since there's no number other than really a 1 in front of this. So I'm just going to rewrite the whole thing. So I'll have 3x to the fourth minus 2x cubed plus 7x squared plus 8x minus 1. But now when I distribute the negative, I get a negative 5x to the fifth, a minus 9x to the fourth, minus 2x squared, but plus 1/2 x at the end. So now I'm just basically doing what I did in the first part of this example. I'm still just combining like terms by adding or subtracting coefficients. So scanning through this whole thing, still there's only this x to the fifth, but now it's a negative, so I'll put negative 5x to the fifth. I'm now going to combine my x to the fourths, but this is different. I have a 3 and a negative 9. This gives me negative 6x to the fourth. Okay, now I have, again, there's only this x cubed here, so that just tags along as minus 2x cubed. All right, so x squareds. I have a 7x squared and a minus 2x squared, so that gives me 5x squared. Okay, now I have an 8x. Now I'm adding 1/2 to it. So if we're still using decimals, then this could be expressed as plus 8.5x. No problems there. And the last piece would be there's a -1, but there are no numbers by themselves on the other expression, so I'll put -1 at the very end. I'll scan across. I know there's not going to be any common terms. And that is it. So we took the difference of those two polynomials. You could, of course, subtract in the other order. So that is, we would place this expression here and vice versa, move this one over here. If you subtract in this order, you are going to get a different answer. All that's going to happen is the sign on each term is going to be the opposite. So it would be a positive 5x to the fourth and a positive 6x to the fourth, and so on. I actually see that there is a slight error that I'm just going to fix. This should really be to the 5th power. I think everything else is okay, and that is it for this example. The other operation that we're going to focus on in this lesson is multiplication. So we added, we subtracted, now we're going to multiply. Now, to do this, we need to use the distributive property, which we already have used this semester. So it's not really going to be too different once you see the pattern for it. It works like this. To multiply this expression into this one, we're going to take each term and distribute it to each term in the other set of parentheses. So just to write that out a little bit carefully, this 5x to the fourth gets multiplied to the 2x and the 3. I'll write out what that is, and then we just repeat this process for the -2x cubed and the +1. But just being careful, if we multiply 5x to the fourth and 2x, we get 10x to the 5th and 15x to the 4th. All right, now we want to continue this though with the this -2x cubed. This gets multiplied to both terms, and the product here is going to be -4x to the 4th minus 6x cubed. And it's getting a little crowded, but I'll try to fit this in. We have this 1 that also needs to be multiplied. The 1 gets multiplied to the 2x, the 1 gets multiplied to the 3, and we get plus 2x plus 3 at the very end. This is it. So we're using the same property that we've used before, the distributive property, but we're just doing it for every single term. The last thing to do would be to look across your expression and combining like terms, and here we go. We have this 15x to the fourth and a -4x to the fourth. Those can be combined. So we get 10x to the 5th, 11x to the 4th, and then nothing else can be combined. So we get -6x cubed plus 2x plus 3, and that's the final answer for this example. And for the last example, I just wanted to try, again, multiplying two polynomials together, but throw in maybe two separate variables and have 3 terms in each expression just to see how that changes things. Just to make sure you understand how the pattern works. It works the exact same way where you can look at your very first expression, start with the x, and multiply this x to the 3 terms of the other expression. So I can write that out. I'm basically saying this x gets multiplied to this 50xy, it also gets multiplied to this 6x, and lastly it would go to the 14. So just simply multiplying these things together, we have x times 50xy. So we get 50, there's an x times x, which is an x squared, there's a y, which doesn't combine with anything, and that's it for the first expression, and we just continue to the 6x. X times 6x is 6x squared, and x times 14 I'll just simply write as 14x. So that's all, and we can now move along to the 2y, and I'm going to multiply 2y again to each term over here. I'll stop drawing the lines that go to it. It's kind of just a visual aid. You don't have to draw those either, but all I'm doing for the next piece is for 2y, I'm multiplying it to the 3 terms in the other expression. So this time, we get plus 2y times 50xy, so 2 times the 50 is 100. X combines with nothing, but now we have a y squared. Okay, so now we have 2y times 6x, so 2 times 6 is 12. We have 1x and we have 1y. And then 2y times 14 is going to be 28y. So this could be, obviously this expression is going to be kind of lengthy, so I'm just going to start writing below this what happens when I multiply this 0.5xy into both, or actually all three of these terms. So here's what we get. We get 0.5 times the 50, which is 25. We have an x times an x, which is x squared. We have a y times a y, which is y squared. So again, I'll take this 0.5xy and now multiply it to the 6x. So we have 0.5 times 6, which is 3. We have an x times an x, which is an x squared. And then we have y, which isn't multiplied to anything, so I'll just copy that down. And lastly, it's going to be the 0.5xy times 14. So 0.5 times 14 is going to be 7. And then we just get x and y. So here it is, all multiplied out, not combined at all. So let's just be a little bit careful and see if there's any like terms. Like terms meaning the variables have to be identical, so same exponents and same number of variables. Let's see. I would just systematically go through and say, okay, here's a 50x squared y, and just scan across if you see another x squared y. Oh, here we go. So we have this and this. We have 53x squared y. You can even mark like, oh, we used that one, we used this one, just so we don't have to keep looking over those again. Okay, so next will be, maybe we'll go to the 6x squareds, and I'll scan across to see if there's any other x squareds. I do not see any, so I get plus, erase that. We get plus 6x squared. Okay, so that takes care of this. Next would be just if we have an x. And looking across, I don't see anything with just an x, so we now get 14x. Okay, so we are done with this one. Now we have an xy squared. I don't see any other xy squareds when I look across, so I'll just copy that one down. Plus 100xy squared. Okay, so we're done with that. Now we have 12xy. Oh, here we have another xy. We have 7 of them, so that's a total of 19xy. So use that, and I used that. And yeah, I'll copy down the 28y. And then we also have an x squared y squared, so that's plus 25x squared y squared. Those don't combine with anything. And that's every single term, so it's kind of a mess, but this entire expression is the final answer when multiplying those two polynomials together, and that's it for this example.